Hello and greetings to everyone. We are going to treat the next thing, which is estimation. We are going to see how to estimate the result of an arithmetic operation by making use of the different methods of approximation. We take this down. Estimation can be performed before starting an accurate calculation to see what kind of answer to expect at the end. That means we make use of estimation to see how the final answer will look like and to know what kind of answer we are to expect at the end of an accurate calculation. This form of rough checking is very useful in spotting errors in calculations. To do rough checks, we take suitable approximations for the numbers in the calculation, making use of the methods of rounding off. That means you either round down or you round up. Let's look at this example. It goes find an estimate for 35 times 64. Take solution. First thing, we are going to start by approximating the numbers 35 and 64 to the nearest tens. 35 to the nearest 10 is approximately, we are going to round up between 3 and 5. 5 is greater than or equal to 5. It is rounded up to 1. We are going to add the 1 to 3. It gives us 40 to the nearest 10. 64 to the nearest 10 is approximately, we're going to round off between 6 and 4. 4 is less than 5, it is rounded down to 0. Gives us 60 to the nearest 10. Now, for us to get an estimate of 35 times 64, we are going to multiply 40 by 60. 40 times 60 is simply equal to, we can easily multiply 40 by 60. We know 4 times 6 gives us 24. Then we attach the 2 zeros. It gives us 2400. And the answer 2400 is the upper estimate. That means the accurate answer cannot go above 2400. Now let's get the lower estimate. Also, we know the number 35 to the nearest 10, it gave us 40. Let's take the nearest 10 to 35 from below, which is 30. 30 times 64 to the nearest 10 is 60, which is from below. 30 times 60 will simply be equal to, we know 3 times 6 gives us 18. Then we attach the 2 zeros, it gives us 1800. 1800 is the lower estimate, which simply means the true answer, the accurate answer, cannot be less than 1800. We take this down, therefore, the true answer for 35 times 64 lies between 1800 and 2400. That means the true answer cannot be less than 1800 and the true answer cannot be above 2400. The accurate calculation can be done as follows. There is an easy way of doing the correct calculation. 35 times 64 is simply equal to, we can express 35 as 30 plus 5 as such times 64. This will simply be equal to, we make use of the distributive property. Remember, we treated the distributive property under the sets of numbers. You can watch that video, you will learn so much. 30 times 64 plus 5 times 64. Next, we can express 64 as 60 plus 4 plus 5 times 60 plus 4. This will simply be equal to, applying the distributive property again, 30 times 60 plus 30 times 4 plus 5 times 60 plus 5 times 4. This will simply be equal to 30 times 60 gives us 1800 plus 30 times 4 gives us 120 plus 5 times 60 gives us 300 plus 5 times 4 gives us 20. And this will simply be equal to, we have to add 1800 plus 120 plus 300 plus 20. It gives us 2240. This is the accurate answer. You will see the accurate answer 2240 lies between 1800 and 2400. We are going to end by taking down the exercises for application on approximating to a given number of decimal places, approximating to a given number of significant figures, and estimation. Exercises for application. Question 1. Write the following numbers correct to the required number of decimal places E to one decimal place. We have the numbers of I. We have 0.34. 2I we have 0.789. 2I we have 6.5. 3I we have 6.5. For IV we have 463. We move to question B. B to two decimal places. For I we have the number 0.7471. 2I we have the number 0.0802. For 3I we have the number 0.006775. IV we have the number 56.384. Question C to 3GP. For I we have the number 0.006648. For 2I we have the number 0.4378. 3I we have the number 10.9999. IV we have the number 999.99999. We move to question 2. Question 2, write each of the following numbers correct to the required number of significant figures, that is SF. For E, 1 SF to 1 SF. For I, we have the number 4546. For 2I, we have the number 2.43. For 3I, we have the number 0.00086. IV, we have the number 0.0711. We go to B, to 2SF. For I, we have the number 0.0485. 2I, we have the number 0.0701. 3I, we have the number 369.997. And lastly, for IV, we have the number 0.0009097. We move to question C. For C, to 3SF. For I, we have the number 0.0000973. 2I, we have the number 0.07999. 3I, we have the number 28.7046. 4, we have the number 154,681. We go to question 3, which says correct each number in the product or quotient to 1 SF, and then estimate the result. For I, we have 44 times 28. For 2I, we have 1.8 times 720. 3I, we have 47 times 62. 4, we have 440 divided by 38. 5, we have 8.1 divided by 3.9. And lastly, for 6, VI, we have 29 divided by 0.72. These are the exercises for application on approximating to a given number of decimal places, approximating to a given number of significant figures, and performing estimations. In our next video, we are going to start by correcting the following exercises for application. Please, if you like the video, share and subscribe to this channel. Thank you very much for watching.